Hey there, welcome back to Farmcraft. I'm John, and Large Marge is back there laughing at me because I'm still not done fixing her. In this video, I'm going to start working on some of the electrical issues. There's several of them. Some I hope are going to be pretty easy and simple. I don't know how this is going to go, but we're going to kind of start one thing at a time. The main things I really need to fix: the temperature gauge. There's 2 oil pressure switches on it. I need to evaluate those and make sure we have that working. There's an alarm system that's supposed to alert the operator if the cooling fan belts break, and that is not working. I need to fix all of those. I also need to fix the high-speed drive. Let's see how much I can get knocked out in this video. So before I start tearing into electrical stuff, I need to disconnect the battery. Well, it turns out that this has a battery disconnect on it. This right here, if you look underneath, is a handle that's supposed to be able to move and allow you to disconnect the battery negative. It does not move, and it would be nice if it did. So I am going to take this apart. I'll clean up all my ground connection at the same time and see if I can make that work. That would be nice. Huh, actually came off. Alright, let's see if anything in here is salvageable. There you can see how the handle is supposed to move. But it certainly does not. Not much left of that one. Well, the contacts look okay. That gasket's a little worse for wear. Yeah, so that's in good shape. Nothing wrong with that. Nothing wrong with this. It's just about the shaft getting frozen up in there. Probably because this gasket failed, water got in and then went down into there and it rust jacked. Let's see what we can do about freeing that up. Actually, I was about to dunk this thing in evaporust, but I just realized this pin here that goes through there, I think I can drive out, and it may allow me to take that off at that point. Let's see if we can do that. Got that. Looky there. Coming. Yeah. I'm actually thinking that shaft has a shoulder in it because it's wider up here than it is down there, so it's not going to come out. You can see the diameter there is bigger than what's coming out down here. Maybe I will go ahead and evaporust this thing. The only way I could get it apart is to take that, which that I think is peened over. I don't know, that seems unnecessary. I just need to get this thing moving. Yeah, let's throw it in some evaporust and see how we do. While that's doing its thing, I'm going to keep working on this ground strap. broke it off. Was kind of expecting that. The problem is I don't think that's threaded in, so that is not going to come off. I wanted to give that one try, but I'm pretty sure that that bolt is probably welded onto the back of this boss here, and then that was welded on. All I need to do is attach this guy somewhere. So I got this bolt, and this will work just fine. So I just need to take that off so that I can weld it, and the weld will all be down here around the head. And it's got a nice flat area for the ring connector to go on and make good contact. So I think that'll work just fine. Now I gotta move you guys because it'll mess up the lens on this camera. All right, I think that's going to work just fine. It did a nice job, but it's still not moving. I'm going to go rinse all these off in water just to get the rest of that evaporust off. Alright, I was hoping after the evaporust this thing would just move, but it doesn't want to. Look at that. See all that junk coming out? Good looking stuff. So something else that may not be apparent here, there is a spring down inside of here pushing this thing that way. This spring only compresses there, but when I pull this out, the spring loading back is coming from a hidden spring that we can't see. But that is working great now, and the oil coming through does not look rusty and dirty anymore. So yeah, I'm going to go with some lithium grease here. This will help repel or resist water intrusion and corrosion, obviously, and should stay put for a long time. Put this little pin back in here. Okay, so now that pin will line up with that slot, and then when you put the handle in, it will lock in position in that little detent there, and it holds these up against the contacts in there. So take the handle out, there's no connection, put the handle in, you've got a good ground connection. I've cleaned up all the contacts. I'm going to put some dielectric grease on here. My gasket. I would make a new one, but this thing is bowed. Like, it's not even close to being flat. So a new gasket is not going to seal unless I did like a really spongy kind of material. I'm just going to do RTV. And if you're wondering, I've made a giant tip on it because I've used it before and it clogged and I had to cut it off to get to the fresh stuff. Obviously, I would rather be able to control the bead better, but yeah, this ain't rocket surgery. And I want to make sure I got a good bead around it so that this will seal out water. That was the whole problem in the beginning. And I'm sure some of you are thinking that this is an awful lot of work for something that's not that big of a deal. And that's kind of true. You can go buy a new one of these. It'd probably be 50 bucks or more, because this has to be able to take quite a lot of amps through it. You can't just get one of those cheapo ones on Amazon and expect it to hold up. It won't. But I'm about to start electrical troubleshooting, so when I'm digging through wires, I need the battery disconnected. But then when I want to go test something, I need it connected. And then I'm going to disconnect it again. And I'll be disconnecting and reconnecting the battery many times in this process. And this makes it easy and fast. So full disclosure, I snapped this thing off when I was tightening it down because this is, I guess it's some kind of plastic. It's just not that strong. It can't be made of metal, otherwise this thing wouldn't do what it needs to do. These have to be insulated terminals. And I have since epoxied it and put some more RTV on it to keep the water out. But I wasn't confident that was going to hold because there's constant spring pressure pushing against these terminals that this needs to resist. So I took a piece of zip tie and put it over there and then tightened those down. And I think that'll work. Kind of annoying. If I have any more problems with this, though, I think it'll be time to buy a new one. This is, well, this is Farmcraft. This is a hack. No doubt about it. All right, good ground connection. Okay, so the first thing I'm going to try to get working is the temperature gauge in the cab. It's very important, obviously, for the operator to know if the engine is running too hot. So, first thing I need to do is find the engine temperature sensor, which is right underneath this shroud.
There is the temp sensor right here. It is on the cylinder furthest from the cooling fan, which is all the way over there, and right at the top. So that's the hottest point of the engine, and that's where they put the temp sensor.
So one of the first things to do is to check the sensor. I've got my alligator clip lead on it that's going down to my multimeter, which is set on resistance. And when I touch a ground, it gives me the resistance reading across that sensor. And now I'm going to take a torch to it and heat it up and see if the reading changes, and that will confirm me that it's at least responding to temperature. I don't know what these numbers are supposed to be, but that'll give me kind of a rough idea of if the sensor doesn't do anything to a change in temperature, well, then the sensor doesn't work. So here we go with some heat. Yeah, definite change in resistance with some heat. Didn't take much at all, actually. Okay, I'm assuming the sensor is okay. Now the question is, why isn't the gauge working? All right, we're up in the cab, and one of the first things I want to do, the temperature gauge is right there, and a lot of these buttons don't seem to do anything. So I'm just going to pull this kind of whole area apart and check the wiring behind it. There could be, you know, loose connections, who knows what. This seems like a low-hanging fruit to check out. There's another thing to check that I'm forgetting here. We'll cover it later in the video, but see if you can spot my mistake. So this thing still has the spade terminals with solder connections to go on that board. I don't think that was ever hooked up. It doesn't look like it. It's always tricky because there's options on machines, and a lot of times the wiring will be there for those options, but they were never actually hooked up. So what I'm seeing really doesn't look too bad. Just a little unsure of how to troubleshoot this since everything is circuits. I wasn't expecting that. It's kind of annoying, actually. And down in here, it's it's just in conduit. I don't see anything that looks worth investigating. I want to get this thing off of here so that I can check it out and kind of get a sense of how this thing works. So these connectors look to be all the same connector. A lot of times they make these things so that you can't put them together wrong, but this looks like you could. So I am going to color code everything. So I've got red, I've got black and gold, I've got red and gold, and then red and black. I've got them all labeled. Let's take this into the shop and see if we can figure anything out. So I got 2 screws there, and then there's a whole bunch of bolts up here. Studs, I should say. That one looks like it's making an electrical connection. Most of them do not. I don't know if that's what's holding it on, but it's very firmly attached. I don't think taking these screws out is going to do it. I feel like it did anything. So I can see the switch is screwed in there and goes through onto the board. How am I supposed to take this apart? Ah. Okay. Yeah, that frees the switch up. Alright, now it's moving. See that? So it would appear that they peened that over to lock that down. And these are all light bulbs. I guess this was an early attempt at security, maybe? Or can I twist those and take them out? Nope. I think so. I bet I voided the warranty. Just a little sticky. And there we have it. I guess the nice thing about this circuit board is it's really just wiring. There's very few components. There's a couple resistors here, switches and bulbs. That's the whole thing. There's another resistor. 3 resistors. And I don't see anything else. There's no diodes or... So I want to see what we got in here. Now the gauge is not stuck. And now I can see it's these 2 posts right there are that gauge. Actually 3. So 3 connections, 2 coils. So I'm just putting this back on. I don't really think there's anything more for me to gain in there. Let me look at this thing. I'm going to see if I can trace where these 3 posts go on the board. Maybe. Okay, so here's our update. I looked at the color code on this resistor, and it's a 330 ohm resistor, and that's what it measures with my meter. So that's good. I don't know what this is. I can't read the writing on it. It also measures 330 ohms. I suspect it's fine. And this one also matches the color code. I think it was 560 ohms or something. But the 3 resistors I found are good. And now I've been tracing the wires. So I labeled this post number 1, this one number 2, this one number 3. And number 1, you start on the other side. It goes over to this, which is that. Crosses here, goes to this trace there, to that. And that goes down to a light bulb that is not there. And then comes up to this, a connector that's not there. It doesn't look like it ever was. This is connection 2, which it connects with a bunch of these other ones, and that is likely the ground, since they're all connecting together. And then connector 3 goes over here and through this resistor comes back to 2, so that seems like it's a bleed down kind of thing. Alright, I'm limping along here. I'm far from good with electronics. So I've got my multimeter, and I am connected on post 2 here. I've already done these tests, but I want to show you what I'm doing. And I went through, I'm on ohms, and you can see I've got no connection. And I just went through and checked all the leads. And I can verify by touching the ring right near it that I do have a connection. So I did this, checking all the terminals, and I found that this one is a direct connection to post 2. Now remember, post 3 came around and through a resistor came right back to post 2. So if I do the same thing on post 3, I should also see a connection, but it should be through the resistor. It should be like 330 ohms. And it is, 328. Let's check post 1 now. I don't find any connection on that post, but here's the deal. That is coming through a light bulb to get to that point. That then comes back here through this, whatever that is, to that post. So the point being, even though this is connected to the gauge, if the light bulb burns out, it's going to lose its connection, and it wouldn't be much of a gauge if it ceases to work because a bulb is out. Even better, that bulb is the battery charging bulb. That would like warn you that the alternator's not working. The other thing is, coming out of the bulb is connected right there, and that connection is this, goes across this resistor to there, and from that point, it goes all over this board. It goes up into here, it goes down to here, it goes down to here. What I'm getting at is this post number 1, I have a feeling doesn't actually have to be hooked up for this gauge to work. Because there's just one wire that goes to the sensor, and I think that one wire is going to be this wire that we found, which has connections with both 2 and 3. So I think what I'm going to do is find the wire that plugs in here, and I'm going to check it for continuity with the wire that actually plugs into the sensor and see if it's the same wire. But the other thing I want to do before I put this back together is I want to make sure that the bulbs work. So what I've got here is 2 12-volt batteries that I use in my little Bosch drills. And I've got them wired in series to make our 24-volt system. And then I can put these across this bulb and see if they work. Yeah. So that's a good bulb. And I'm just going to go through and we're going to check all of these. Well, surprisingly, every one of these bulbs works. That is a blank spot on the gauge. And this is also a blank spot. That is where the battery is not charging. Well, I know the alternator doesn't work, so I don't want that just sitting there on. But yeah, all these bulbs work. And really all I want to do before I put this back in is polish this up so that I'm going to be able to see. Now, there's a possibility I'm not going to be able to make this gauge work, in which case I'm going to have to figure something else out. The problem is this is not a regular old engine. You know, you can get temperature gauges for engines anywhere and everywhere, but this is an air-cooled Deutz, and I don't know how its temperature gauge works, like how hot is too hot, and I mean, you could look that kind of stuff up, but getting it right might be tricky. Now, I'm not sure how much I accomplished tearing that apart, but I don't think it was a waste of time. I mean, the key thing is that I confirmed those 3 posts control that gauge, and if I can get that gauge functioning, wiring directly to these posts, well then that'll be a huge success. That's really my goal with this thing. Obviously I need the swing brake and the drive to continue to work, and I want this is high-speed drive here. Okay, so here's the circuit board. This is the wire that I think would be hooked to the temperature sensor, and this is the black gold connector. So over here, this is the black gold connector that I labeled before I unplugged it. So I've got that pin connected to my meter. So we're now going to go to the engine temp sensor. I want to see if that wire is going all the way to the engine temp sensor. Sensor right here. So this is the wire we want to check. And now I'm just going to plug, and that goes to my test wires here, which is just a piece of lamp cord. All right, so we're back at our meter. The other end of this wire is hooked to our engine temp sensor. The other side of the gauge, let me put it on ohms. No connection. The other side of the gauge is hooked to the wire we're interested in. And nothing. No connection. Wonder why the gauge isn't working. So here's the schematic that I have. The engine temperature gauge is right here. It shows the 330 ohm resistor going across it, just like I'm seeing. And it comes over here to a pin that they've got labeled 20. And it also connects, okay, yeah, those are also connected together with some other circuits. But then they've got this 330 ohm resistor that we saw that is connected to a bunch of different things. The first one being the alternator, that charging light, and the air cleaner, the engine oil pressure, hydraulic filter. But number 20 is our engine temperature gauge wire, and it comes over here into the main control box. This schematic isn't detailed enough to really show you where it's going, but it does have a number 20 up here that then goes out to the engine harness. And number 20, I guess it is detailed enough if you follow the numbers. Number 20 here goes to the engine temp sender. So that wire, number 20, goes into the electrical panel and then comes out of the electrical panel to the control panel. That's what we'll call the little box that I've been working on, and over here. So I am not getting a connection between 20 here and here. So the electric panel has a number 20, so we need to find that and see where the wire is not making connection between the gauge and the sending unit. Alright, so here's our electrical panel. More non-color coded wires. Bunch of fuses that are missing. I've been sitting here scratching my head on this thing. This is an absolute mess because I just don't know what has been changed. So in this box, it looks like there were relays on this board that have been desoldered. There's loose relays sitting in the bottom. So, man, it's tough when you're coming into this and you just don't know what's been changed and how things are supposed to be. Getting out the manual, the RTFM, I see that fuse 1, which is labeled F17, it's a 5 amp fuse, is for a lot of things I'm interested in. Cooling belt switch, hour meter, engine oil pressure, air restriction cleaner, I don't need that. Cooling belt lamp, that would be nice. Hydraulic filter warning lamp, don't care about that. That's telling you when your filter needs to be changed. Same with the air cleaner, I can do that the old-fashioned way. Alternator warning lamp, engine temperature gauge, look at that, and low fuel level lamp. That would be nice. Keep me from having to bleed the system if I run it out of fuel. Well, that fuse is right here. It's not in place. It also doesn't have the relay labeled K1. Looking at number 1, it does look like there's a relay there. It also looks like there's a relay beside it and then no relays for several slots. Mine's the opposite. No relay, and then relays. What the heck? I mean, it is so hard for me to know what's going on here.
A few moments later.
Now, I've got this wire hooked to the wire of interest in the cab, and probing around on this board with everything plugged in, you get lots of like 3 ohm to 220 ohm to several mega ohm connections at various different places. The lowest resistance connection I got is on this wire, and it was like 1.8 ohms. This wire is also labeled 0, which is what the one in the cab is. So I think that's our wire, but in order to really verify it, I think I'd have to unplug everything, because like here's another wire labeled 0. Man, they made this fun for sure. Now I should show you this. This is the wire that was supposed to go to the fan belt alarm switch, and it's got bare copper on it. It's pretty tore up right there. And this is the wire that goes to the air filter. I see some bare copper, it doesn't look too bad. I mean, I suppose I could put a fuse in that slot and see if it blows immediately. I need a 5 amp fuse. I did take my meter and check both sides of that to ground, and I do not see any ground fault. So I've got 2 jumpers on the both sides of that fuse holder, and I've got a little 5 amp fuse here. So I'm gonna go turn the ignition on, and we're gonna see what happens. We're turning the key for the ignition. Now I haven't started it. But yeah, see, like that light works. Huh. That low oil light is lit. I've not seen that before. Interesting. I'm going to take a mini torch at that temperature sensor and see if I can get a readout on this thing. I am just below the white. Let's go ahead and start it. I want to see if the oil temperature light goes out, because I want to see if the temperature gauge is going to work with the engine running. For some reason, maybe it would. That would be nice. Now, I just did notice something when I turn the ignition on. I'm turning the key here. That temperature gauge moves a tiny bit, like it's trying. Who knows? Maybe when the engine's running, it actually would work. That would be cool. And let's start her up. Check that out. Oil pressure light works. That's nice. I wonder if the hour meter works now. Let this thing run for a while. We're at 7221.8. Yes, it works. I think it's actually working. It's definitely responding. It's not coming up a lot, but I can't really work the machine that hard here. But at least I've got something to look at. So if it gets significantly hotter than its normal operating temperature, I'm going to see it. I guess what I'm saying is I'm not sure if it's actually accurate. Like maybe it should be more vertical right now. But I've got something to look at so I can see if things are changing. I bet you it's accurate because I'm not digging. I'm not pushing the engine hard. So I just measured the temperature at the temp sending unit, and it was 150 Fahrenheit, which is not hot at all. The upper operating temperature for an engine like this, I think, is 250, 260. It's higher than most engines because you don't have to worry about coolant boiling. It's air cooled, so the temperature can go up higher without any trouble. So I think that thing's working. The engine's not very hot right now, and that's what it's showing. It's in the green, but it's not very hot. Sweet. And I just shut it down, and the oil pressure light immediately came back on. Little victory, I'll take it. Kind of crazy. That fuse is fine. I wonder, did they take it out just because they needed it for a different slot, or did they remove it for a reason? I suspect that they probably had a short on those wires back there because they were all like wrapped around everything when I got the machine. Well, in my typical fashion, I came around to that in a roundabout way. I'm really surprised that this fuse has fixed 3 of my problems. The hour meter's working, the oil pressure switch is working, temperature gauge is working. That's awesome. All right, I'm really kicking myself for not checking the fuses earlier. I might as well explain it so you don't make the same mistake. I read that book cover to cover when I first got it, and I did look at these fuses, but in my mind, now that I'm thinking back on it, I knew I had so much bad wiring on the machine, I didn't want to go sticking a fuse in there until I had time to make sure that I wasn't going to damage something, cause a fire, or whatever. But I should have thought through that more when I started working on it. But in my mind, I had kind of already read through the book. It didn't stick in my head that I was missing a fuse. So first rule, don't be an idiot. Check the fuses first and read the manual. But I think the troubleshooting I was going through is probably still a little worthwhile. Tracing wires and trying to figure out where you're losing your connection. But since it's working, I'm not gonna keep fiddling around with this mess. Next thing we want to work on is the high-speed drive. It's supposed to have 2 speeds for tracking, a low speed where it has higher torque, and a high speed to obviously go faster. And it will only go in low speed, and you can see it's rather slow. So we're looking here at the electrically actuated hydraulic valves called the solenoid valves. And this is the previous repair that I did. I found that there was a bad connection in one, and that's why my spring brake was stuck on. I assumed I wasn't going to be able to get these connectors. Well, many people commented these are a standard DIN electrical connector. They're readily available, and sure enough they are. It's, I think, the only easily found part I've had to come across on this machine that I can think of. Down here, I think it's this one, I'm not sure which, is the high-speed drive. So I'm hoping that I have a similar problem, and in fact I probably ought to go through and replace 1, 2, 3, 4, 5, 6. I actually have 6. I bought some that have an LED in them, so it actually, you can look at it and tell if it's getting electricity. So that's really nice for troubleshooting. But then a very nice viewer sent me one because of this job, saying you need to fix that right. And of course he's right, I didn't know it was that easy to get them. But that means I have 6. So let's start out with this farmer hack here. Who fixes something like that? That's ridiculous. If that washer was just a tiny bit bigger, it would go over that wire. I'm gonna go drill that out. Now, drilling out a washer on a drill press or with a hand drill is rarely successful in my experience. You end up messing the thing up. But on a lathe, usually, you can do it. Hey, there we go. Yeah, this goes on. Now we get this all the way on. And then tighten them down. You guys even see what I'm doing. It's kind of tight quarters in here, so I can't get the camera in a better position. There it is. So these things actually come with a little rubber seal. Kind of like these connectors. You tighten that down. It's like a gasket, a little rubber gasket, and water can't get in there. Cool. Let's get these others changed out. So this one right beside the swing brake is the control shutoff solenoid, if my documentation's right. And it's actually not something that I need to use. What that is when you put the armrest up, it disables all of the controls. And I don't even think I'm gonna fool with that one because that mechanism is destroyed and I don't think it's ever gonna get used. So I'm gonna leave that one alone. If you're wondering, the control lockout, you're supposed to be able to put this up and it's supposed to stay up, which it does not. And this is a button that will make a contact when it is down, but if it's up, it's supposed to lock out all the controls. And the wiring behind there, I had it apart when I was doing the control pattern, is an absolute nightmare. It's all destroyed, so it has long since been disconnected, and I think it'll probably stay that way. So based on what is in my manual, if I had to guess, this would be the high speed. Huh. Okay, there's no connection there. So if I'm not mistaken, this is the low speed solenoid and this is heavy lift solenoid. The heavy lift light comes on in the control panel, so I'll be interested to see if that's actually getting back here. This I think is the high speed solenoid, and this is the drive brake solenoid. The low and high speed should toggle between each other, I guess. I would think you'd only need one signal to, it would be default low, and then if you give the signal, it would go to high. I don't know why you would need two, but anyway, that's what it says in the manual. All right, let me go up in the cab and I will put the ignition on and then I'll call out as I'm changing things. Ignition on. Okay, the swing brake is currently off. Now it's on, now it's off. Tracking is currently on, now it's off, now it's on. Heavy lift is currently off, now it's on, now it's off. It is currently in low speed, now it's high speed, now it's low speed. Ignition off. Slow, very slow progress. But maybe some good news here. So I found this in a manual that was in French, and that is the model of my machine. And it actually has more information than the manual that I have that's in English. And I ran the key through Google Translate and came up with this. All of these K labelings are the relays. See, K2, K3. So that is my circuit board. It turns out, if you look on here, K1, K2, K3 not used. K4 is flow re-injection relay on translation. I'm not sure what that means. K5, K6 not used. K7 is a cylinder change relay. K10 is a buzzer relay. But I went through all the relays, and all these that I have labeled with an X are not used. K4 is used, XX, and then yeah, it turns out the only ones used are K4, K7, K10, K17, and K9. That's the main relay there. It hooks directly to the battery and provides power to the circuit board. So it turns out that most of my slots that are not populated, like these two, according to the French manual, are not used anyway. K3 is not used. I labeled with a white tag the ones that are. So that one's used, not. That one's used, not. This one, K10, is a buzzer relay, which I'm pretty sure is for the horn. Don't need that, at least not controlled through a circuit board. Not used, not used, not used. Same with a lot of these fuses. The majority of them are not used or not necessary. They're doing things like lights and things like that that I'm just not going to run through this control board if I hook them back up, because it's just way too complicated and way too difficult to deal with. I mean, there's diodes on this thing. Who knows what's on the back of the board? It's too far gone to try to bring this back, I think. So like this one's not used. This one's not necessary. This one's not necessary. Many of these are not used. F5, which is this one, is used. F18 is used, and it has a fuse in it. And then F17 is used, and that's the one that I hooked up temporarily with this little 5 ampere to make the oil pressure and the hour meter and those things work. The relays, with the exception of the buzzer relay, the rest of the relays are here, and the ones that are not populated aren't a problem. Now, there are some relays over here, and they're not labeled, and I'm not sure if those were, they don't look like they weren't stock. I don't know, but the point is, this board, while being very confusing, I think a lot of it, these unpopulated areas are not a problem. That was a long way to get to that. And also, like all these fuses here, these are not used. So also not a problem. Okay, enough yakking on that. And of course, all that is assuming that this French manual is correct for my machine, because there are some other parts in the exact same manual that I found that I know are incorrect. That's what you get. Nothing but fun. I'm 99% sure I have these solenoid valves labeled correctly. The French manual actually was incorrect. For instance, it had the swing brake. I know that's the swing brake, 100%. And it had it labeled on this side. So I have to discard what is in the French manual for that. My manual made sense. It has the swing brake labeled here with the control cutout here. I know this is the drive brake because it lit up, and my manual had drive brake with high speed solenoid right beside it. So I think that's the high speed, and then the only two remaining were the heavy lift and the low speed. What I want to try now is, I just turned the ignition on and assumed that these would respond. Maybe you actually have to track for it to work. So I am going to put the camera on this and actually track the machine and see if I get any lights from anything in here. So let's do that. See, if I turn heavy lift on, the light comes on, but I don't think it does anything back there. These don't light anything up, but they do something back there. So this is tracking, so this allows you to track. So that's going to be drive brake on, drive brake off. And now let's track a little bit. High speed is not on. Here's high speed. Low speed. High speed. Not doing anything. Okay, so we are making progress, and that was an unexpected result. I saw that both heavy lift and low were coming on intermittently while I was tracking, but the high never did. I've made some progress going through the French manual and looking at the wiring diagrams with some help. And I think at this point my plan is actually to fix this thing to work the way it originally did. Let me show you why. So we're going to go look at the wiring diagram in a second, but I want to call your attention to a couple things here. If you look at these, that's labeled socket 40 or junction 40. That's 41. Underneath there you can see 42, 43, 44, 45. Well, if you look on the connectors, they're actually labeled. Like that's number 6, that's 5. Down here is 4, 1, 2, and 3. So all the junctions are labeled. There's a number for the socket, and then there's pins on the connector. So let's go look at the wiring diagram. This is the electrical cabinet we were just looking at. You can see all the junctions labeled. This is kind of the layout. That's how the box actually looks. This is how part of it is actually wired. And this is the automatic translation function. That's translation in this case means like moving, translating back and forth. And it explains how it all works. And this diagram has exactly what I need on it. It has S8 is the switch in the console. That is the high-speed drive switch. And right here, 36, they have labeled the displacement change solenoid valve. Well, that's the high-speed solenoid valve. 37 is the heavy lift solenoid valve, which it turns out that is used in the movement of the machine as well as doing heavy lift. It comes on automatically. And then this is the low speed valve. So these are the electrically actuated solenoid valves that are involved with this function. So when we turn on high speed S8, we are sending power. So this is our power supply right here. Comes through F18 and provides power to a bunch of different things, but if you come down here, it's providing power to switch S8. So when you close the switch, you turn it on, you're sending power through this wire 121 up to relay K7. But you're sending it to this pin, and until the relay throws, because it's normally open, you can see it's not going anywhere, until that throws and connects 3 and 5 together, you're not going to get any effect. So if I just go up in there and turn high speed on, the solenoid valve is not going to come on. But you can see that the opposite side, this pin 5 here, goes over to the high speed solenoid valve. So I'm not getting voltage on this wire, and it comes from relay 7. So you can see we're already making real progress on, okay, now I can start to troubleshoot here. And what's even better about this is these are junctions. These are connections here. And that is 39 pin 6, 56 pin 4, 56 pin 7. You can, all the information is here. So I can go to the board, I can find, junction 39 and pin 6. I can check right there to see what's going on with this relay or this wire. I can go to junction 47 pin 1 and say, does that have any voltage on it, to troubleshoot this. So this is fantastic, and I have to thank my brother-in-law. He's an engineer, and he's really good at reading these diagrams. I am the polar opposite. I'm not an engineer, and these diagrams make me nauseated. But now that I understand it, it's actually pretty cool, so I'm kind of excited. But what he figured out, and I don't know exactly how he figured it out, but on this diagram, right here, these are pressure switches. He just said that's got to be your pedals. That's got to be your forward and reverse. And we did some checking, and it turns out G is left and D is right, and this is forward and this is reverse, the AV and the AR. Those are indeed the foot pedals. And the foot pedals have electrical switches in them that are involved in making this system work. And I was totally unaware of that. But now that I'm seeing it, a lot of this makes sense. So here's the deal. When most excavators are in high speed, they are traveling forward or reverse. You usually don't have enough torque to be able to turn, because those tracks fight against each other and have to skid. So you need high torque to turn. In other words, if you're in high speed and you try to turn, it's just not gonna be able to do it. And that's exactly how it is in my Yanmar. When I just have a little foot pedal that I press to put it in high, and it'll go. But if I need to turn, I've got to let up on that foot. If I try to turn without letting up, it'll just, you'll hear it straining, but nothing happens. So this thing is set up so that it automatically, when you put it in high speed, if you put both pedals forward or both pedals reverse, it will kick on high speed. This is what it's supposed to do, and it will travel as fast as it can. But if you stop, take off one pedal, it's going to automatically come out of high speed, go into low where it has more torque, and allow you to turn. And then when you do both again, it goes back to high speed. So it's kind of managing it for you, whereas on the Yanmar, I have to manage it. And when you're in low and you have one pedal forward, one reverse, you're really trying to turn, doing a zero turn essentially with it. It turns the heavy lift valve on, and that increases the pressure in the system and gives you more torque out of your motors. That's what we were seeing on those lights. The heavy lift and the low, these two together, were coming on. So that part of the system is working, but high is never being energized. Sorry for all the chatter, but I mean, this is how electrical work is. You just have to go through this. So if you look at this, these are diodes. Those are just involved to prevent backfeeding in the system. Let's look at the explanation of function here. Automatically switch back to large displacement, max torque, so low. Automatically switch back to low as soon as the direction is changed. Reverse action of the two pedals are just one. Return to the working position as soon as moving is no longer requested. It also is involved in the chain cleaning function. So S8 is the displacement chain switch, that's the high speed switch. S10 is the chain cleaning switch, and S16 is the heavy lift switch. K4, it's one of the relays. K7 is one of the relays, and K14 is the chain cleaning relay. Got the high speed solenoid valve, the heavy lift valve, and the low speed valve. So this is explaining how it's wired, and it's interesting because it sends voltage to the left pedals, but not the right. If you push the left pedal forward, action on the left pedal in forward gear, so you close this switch here by pushing your left toe down, it is going to, this bold wire here is your incoming voltage. See, that comes up here through the fuse. So it's going to send that voltage through wire 454 and diode V9, and then it gets on wire 454 and it goes up and it energizes relay K4. So if you push the left pedal forward, K4 is energized. The relay is going to flip, and the power right here is going to go from 3 to 5. We follow that over, and it's going to go here. Splits into two directions. There's a diode there. But it comes down here to the low speed, and it goes through here to the heavy lift. And that is exactly what we're seeing. That circuit works. When I used the pedals, we were seeing both of these come on. So when you put the left pedal in reverse, the same thing happens. It sends the power here through wire 454 and through diode V8. It just uses two different diodes for that same function. Now if you just push the right pedal forward or reverse, there's no way for the power to get from the left pedals to the right. You have to close this switch to send the power over there, or close this switch to send the power over there. And that's what it's saying here. No electrical impact because wire number 455 will never be supplied with the right pedal. Kind of an interesting way that they've wired it. If you do both pedals forward or both pedals reverse, you're going to energize K4. You're going to close this switch, and this is tied together, so 454 is going to energize K4. But it's also going to close this switch and energize 455, which comes up to K7. So that is now energized. Now, if switch S8 is open, nothing's going to happen. Switch S8 comes to this point right here on relay K7. So if S8 is open, there's not going to be any voltage right here, and closing that switch, yeah, the relay's thrown, but it's not doing anything. If we close S8, then voltage crosses here, and we send voltage to the high-speed solenoid. And that's what we're not seeing. If both of them are forward, the same thing happens. The voltage here gets sent to the other pedal, which comes down here and energizes both relays. If that switch is closed, we turn on the high-speed solenoid. So cross action of the two pedals, if you have one forward, one reverse, you're trying to do a zero turn. As soon as the translation is reversed in relation to the other, wire number 455 can no longer be supplied, this wire going up to K7. So K7 is not going to be thrown, or the high-speed solenoid will no longer be energized. So if you got them both forward, both reversed, the high-speed can work. But as soon as you flip them or stop doing the two together, you're going to lose your high speed, and it's going to go into low speed and allow you to steer. So what could be wrong here? It could be that one of these switches is not working, or multiple of these foot switches is not working. It could be that some of these wires are broken, but I now know how to check them. This is wire 455, and it is junction 39, pin 6, goes up to terminal 1 on relay K7. I can troubleshoot this now. I hope I didn't bore you to death with all that explanation. I find electrical difficult to work on, but even worse to try to film and explain. So much of it is conceptual. I can show you a wire, but we have to just kind of talk about what's happening. So I'm going to go try to troubleshoot this thing, and I will let you know what I find. All right, well, this is annoying. We are underneath the cab. We're looking up underneath the pedals. And sure enough, the left pedal has wires going to it, just like in the diagram. And those are pressure switches on the hydraulics coming from the pedals. So it knows when you're pushing it forward or reverse. But there are no wires on the other side. I thought, well, maybe somebody removed this stuff, but there's no other wires to be had up here. I don't get it. So yeah, this is confusing to me. I felt like I was on the right track, but when I only have wires going to the left pedal and not the right, what do I do with that? And of course I thought, well, those are just pressure transducers on the hydraulic line, so maybe they're further back on the line. I followed those things way back there. I don't see any pressure transducers on those lines. The wiring that is coming out here comes out of the harness. This all looks original. You can see the brown paint. And, this was the horn. And then this other one over here is going to this light. And then there's one more that's going to the 24 volt outlet. These things are all accounted for in the manual. So I don't see anything missing. So I'm going to do another test here. I am going to track just the left pedal forward, left pedal reverse, and then right pedal forward, right pedal reverse, and see how these things respond. If the wiring diagram is right, when I do the right pedal, I don't think these things will come on. I think it'll come on with either direction of the left pedal, at least according to the wiring diagram. I'm going left track forward, left track reverse, right track forward, and right track reverse. I'm turning the high speed switch on, and we'll do those again. left forward, left reverse, right forward, right reverse. So at this point I'm thinking I should just hotwire the high-speed solenoid and see if this thing's even going to work. There's a lot to think through on this, a lot of different ways you could do this, but here's kind of where I am. My concern is that I've got a low-speed solenoid and a high-speed solenoid, and what happens if they're both energized at the same time? I don't want to cause a conflict and break something. A lot of the parts on this machine are going to be very difficult, as we have established. I don't want to ruin my travel motor. But looking at the travel motor, and this is from the French manual again, the change in displacement is carried by modifying the inclination of the plate. So there's a swash plate. You change the angle, that changes the displacement of the pump, and it spins faster with less torque versus slower with more torque. And then it goes into a reduction gear. This reduction gear is actually what is your final drive. The hydraulic motor is the travel motor. The gear that it's going to is the final drive. Anyway, A is the left reverse power and B is the left forward power. So this is A, that's left reverse. This is B. So basically this is forward and reverse hydraulic supply. Z9 is, this is the translation, arrival of the displacement change control pressure. That is to change the displacement. In other words, that is high. Z9 is this tube right here. Pressurizing Z9 here is how you put the motor in high. Z10 is the spring brake. That was the line that we had to replace because both of them rusted out. And then, this is funny, F is the motor irrigation return. That is the case drain. That is any leakage internally in the motor is going to go through F right here and go back to tank. Looking at this diagram, there is nothing on here to prevent both the high and the low to be on at the same time. And I think what's going on with this low and the heavy lift is the hydraulic pump is changing and the valves are changing how much oil is being sent to the motors. And under what pressure. The heavy lift increases the pressure. From the motor's perspective, down here, I don't think it really cares what's going on here. It's either going to be a little stronger or a little less. It just doesn't matter what those are doing. The high is the only thing that it actually responds to with this line. Because my high-speed solenoid is not coming on, I have yet to pressurize that. Hopefully when I pressurize it, I'm not going to spring a leak, but it could happen. All that chatter to get to this, I do not think there's any problem with a conflict. I think I could easily hotwire this high-speed solenoid and see if it works. But I'm going to do some basic troubleshooting first. I want to see if the switch goes through wire 121 up to junction 38 pin 2, and then from there it goes to relay K7. So I want to look at this junction and see if this switch is sending voltage to it, because it should be. And if it's not, well then I need to go to that control panel and figure out what's going on with the voltage there. And if I can confirm that voltage is getting to the relay, then the question would be, is the relay not functioning anymore? But if I can't troubleshoot this pretty simply just in this little circuit here, because these foot pedals is going to be a big pain. If I find something here and I can fix it, maybe it'll work and we'll be done. If I can't, I'm going to hotwire it and directly power this solenoid and verify that I actually do have high-speed tracking and just see how it works. All right, I am up in the cab. I've back probed with that green wire the output of S8, the switch to go into high speed. And it should get voltage when that switch is on. Right now the switch is off and we have no voltage. Switch is on. And we go up to 20, and it seems like it's off again. It seems like the switch is a little bit goofy. If I wiggle it, the voltage will move around a little bit. I'm wiggling it around right now. But for the most part, it's sending 24 volts. It does make me wonder, though, can that voltage carry any current, since it seems to be doing stuff like that. See, that time it was at 15 volts for a while. Well, I just discovered something else I wasn't expecting. Check this out. I don't know, it looked like those things were all soldered in place. I guess because it just looks so rough. But they're not. They just press on there. So that's cool. Pin 3 of the relay, the top one right here, is where that wire should be sending the 24 volts that I just checked inside the cab. So let me see if I have voltage there. So I am checking the voltage on that pin right now, and there's nothing. So if we follow that junction 7 pin 5 wire 121 over, it comes here to junction 38 pin 2, and up on the board this one is 38, but 2 is this right here, and it's not populated. Can you guys see that? So that is 38. You can actually see it says it on the side too, but it also says it on the board underneath. And this wire is missing. So according to the wiring diagram, that should be the other end of that wire, and there's nothing there. So where does it go? Clearly this wiring diagram is not for this year machine, unfortunately for me. And I have the other end of that wire hooked into the J7 pin 5 plug, which is unplugged. So I'm just checking for continuity, and it should be continuous with this right here, and it is not. I have an open circuit. So I've definitely identified the problem. I don't have a connection between the switch and here. You know, maybe that's all I need to do, figure out how to hotwire that. Also on our diagram, this is 38 and this is pin 2. This should be continuous with this, and it is. What the heck? What happened to that wire? I'm kind of at the heck with it, let's hotwire it stage. But I think the best way to hotwire it is right here. So what should happen on this relay, the solenoid is across there, which connects the top terminal with the bottom one and sends voltage to the bottom one. So basically I need to send voltage to this terminal right here, and I'm gonna do it through my trusty little switch so that I have a little control over it. So that plugs right in, and then this just needs voltage somewhere, and I've got plenty of options here with fused power. This thing's actually supposed to be fed through a 5 amp fuse, which this is one right here that's not being used. Just put that on the other side, and now when I throw the switch, we should see the heavy solenoid light up, and it does. Here we are up here. I think I just said heavy solenoid, I meant high speed. The high speed is right here, and that is the one that has not lit until now, and there it is. Yeah, I can definitely hear it click. I should be able to track this thing, and if I flip that switch, it should go into high. Hope I don't break anything. Okay, so I'm going to start this thing up. We're going to track a little bit in low, and then we're going to flip the high speed switch and see what happens. Hopefully we're not going to see oil go flying everywhere down here, and we're not going to hear any terrible noises. I'm going to have the switch right in my lap so I can turn it right back off if I need to. Kind of makes me nervous because that wire not being populated makes me wonder, why isn't it there? I just hope I don't destroy anything doing this. Anyway, shut up, let's do it. All right, so this is normal tracking here, and this is high. Look at that. It works. That's way faster. It's like twice as fast. So this is normal, high. Sweet. Well, look what I found. Another wiring diagram. And this one has some differences on it. Doesn't give me a year, but it's for the same model, so this actually might explain my confusion. There's K7, there's K14, that's the track cleaning. It's interesting, I don't have K4 being used here. And K4 is the one that's interacting with the pedals on the other one. And I don't have those wires. And on this diagram, I don't have that relay, so that's actually a positive sign. But what I do have is K2, which is labeled as not used in the other manual. Isn't electrical diagnostics fun? especially on old equipment when you don't know you have the right manual. So looking at K2, if you follow it along, it goes to the drive brake solenoid and the drive brake switch. So K2 gets energized, it throws the solenoid when the drive brake switch is on and is going to connect pin 3 with pin 5 and send that over to K7. K7 is the one that I was trying to turn on with the high-speed switch. So here's the high-speed switch on this one, 7.5, same pin there, and it goes to 36.6. So that's supposed to go through a K2 relay, and the purpose of that is to make sure you don't try to drive it in high speed with the drive brake on. Makes sense. But let's go see if this diagram fits with what I've got. So I need to check junction 36 pin 6 and see if that's wire 121, and does it go to K2, which pretty sure mine doesn't have a K2 relay in it. That is junction 36 right there. The pin 6 is the top left. There is a wire there. Can't see what the number is. This wire right here. 121. 121 should be going to pin 3 on the K2 relay, which is not there. And it is. How about that? So then the output from K2, this relay, should be the input to K7, the one we're trying to get to. It's not a perfect connection, but it's a connection. All it needs to do is trip the relay. I think 0.8 ohms won't be a problem. So if I'm not mistaken, all I have to do, put one of these relays in the K2 position, and I think now it'll work. That's assuming this relay works. Recall I had several loose relays sitting in the bottom of this box. Let's test them real quick and see. So you can see that if you go across pin 1 and 2, that's going to activate the relay and cause pin 3 to connect with pin 5. It's normally connected with pin 4. 1, 2, 3, 4, and 5. So normally 3 and 4 are connected. When there's 24 volts across these two outer connections, it's going to flip the relay and 3 should be connected to 5. So let's test that real quick. I should get some resistance. This is across the coil. So yeah, 230 ohms across the coil. That's probably right. So 3 should not be connected to 5, and it's not. It should be connected to 4. And it is. Across the control, and we should hear a little click. Yep. Okay, so now it's thrown, and we should see no connection between 3 and 4 now. No connection, and now we should see a connection between 3 and 5, and we do. So the relay works fine. I tested all the other relays, and they all work. So I put this relay into the K2 position, and amazingly that probably is going to fix this. I think that's all that ever needed to happen. Oh, there it did. Interesting. Yeah, it did speed up. Okay. Wow. All right, it's working. Why did it have to be that hard? Let's go. Oh yeah, that's faster. Much faster. How about that? So now that I've got the hour meter working, I can actually write the hours on my filters and know when they need to be changed. And the fact that all it was a fuse does make me think that that meter is probably not terribly far off, but you never know. Could be 7,000, could be 17,000. So I don't know who you are, why you did it, or where you are, but whoever pulled that relay out, I hate you. Well, there you go, guys. This video's gotten long enough, but we definitely made progress. I think it took a lot longer than it should have for me. Like I said, electrical work is not my forte, but I did finally get there in the end. We now have a functioning temperature gauge, a functioning hour meter, an oil pressure switch, and the high-speed drive actually works. So that's really cool. What I have left to do is the alarm circuit for the fan belt, and that's going to take some doing. And before I go tracking this thing around at high speed, I need to get the tracks tensioned properly because they're definitely too loose. And doing the track tensioners is probably going to be a big job. We'll see. So I will be working on that. Thanks for watching. We'll see you on the next one.